Good morning, class 12 and the improving students. It's very good to talk to you once again. In today's lecture, we are going to focus on the chemical properties or chemical reactivity of formaldehyde. As we have already covered the physical properties and the method of preparation of formaldehyde. Today I will continue with the explaining various ways how formaldehyde reacts with other compounds. So the first chemical reaction is that I'm going to discuss with you is the oxidation of formaldehyde. I have shared with you previously in the lecture that all alcohols are oxidized to aldehydes and all aldehydes very easily are oxidized to carboxylic acids. Ketones are not oxidized. So oxidation is a simple reaction that can differentiate between aldehydes and ketones. So when formaldehyde, let's say the first aldehyde, is oxidized, the oxygen comes from a chemical reaction between K2Cr2O7 and sulfuric acid concentrated. This atomic hydrogen is very much reactive and it reacts with the only carbon or primary carbon, you can say, or the only carbon of the formaldehyde, and hence it becomes H, C double bond O, and then OH. So oxygen bonds between this carbon and hydrogen. Now this group is carboxylic. When a carbonyl, carbon double bond oxygen bonds with hydroxyl, it's called carboxylic group. With only one carbon, it is the first carboxylic acid. Have been discussing already, it is called formic acid. And by the IUPAC rules, it's called methanoic acid. Because carboxylic acids have the OIC as their suffix. So a simple way of converting methanol to methanoic acid, or you can say formaldehyde to formic acid, is oxidation with the help of potassium dichromate and sulfuric acid, a very strong oxidizing couple, right? So this reaction you should all remember and you should be able to do, because it is a very common reaction for examination. As I told you earlier, it's a convert reaction. Convert. In the annual paper, the one question in the long section is about convert this to that, convert methanol to methanol, like the ones we have learned yesterday, or convert methanol to methanoic acid. Like this is a very important conversion reaction. I will recommend you all to understand it, write it, and of course learn it. The second chemical properties are about the addition reaction. Addition reactions. Now, formaldehyde does the addition reactions. Just like all carbonyl compounds of carbonyl group. If you know the carbonyl. The carbonyl is basically carbon double bond oxygen. This is carbonyl group. Now this one bond is sigma and the one bond is pi. As I have taught you hybridization, the carbon is sp2 hybridized. Now carbon is sp2 hybridized and this bond is the double bond, but carbon's first choice is sp3 hybridization. So if you have any and pi electrons are delocalized, they're not fixed in their position, so they pretty much attract any compound which seeks electron. Now oxygen, being more electronegative, pulls these pi electrons towards itself. It makes oxygen partially negatively charged, leaving behind carbon partially positively charged. So if there's any species, let's say plus and minus, electrophilic species is available, okay, what's going to happen? What's electrophile? Electron seeking. If you guys know, they will attack on this pi bond, thereby pi bond will break into two new sigma bonds, and you can see that carbon single bond oxygen and the positive A will reach the negative oxygen. So OA, there will be a sigma bond between oxygen and the incoming electropositive species, and there will be a B bonding with the carbon. This is an addition product. A chemical reaction in which two substances combine into one is called addition reaction. Such reactions are with all compounds having pi bonds, such as alkenes and alkynes, and aldehydes have a carbonyl group. So obviously they also do addition reaction, and these reactions are just another strain or example of the addition reaction or electrophilic addition reactions. If you guys know, electrophile are those species which seek electron. So when an addition reaction takes place with the help of an electrophile, it's called electrophilic addition reaction. The basics of these reactions we already have learned in the 7th chapter while I was teaching you the chemical reactivity of the alkenes. Alkenes have a double bond, and the double bond mostly breaks during chemical reaction to make two new sigma bonds. So this is the addition product. So the second part of the chemistry or chemical reactivity of the formaldehyde basically deals with the addition reactions, and now we will go with examples, like one by one examples of the addition reaction. So this is 1, this is 2, and this is the part 1. I'm gonna make it in Roman because this belongs to number 2, addition reaction. Addition of hydrocyanic acid, HCl, hydrochloric acid, or hydrogen chloride, HF, hydrofluoric acid, or hydrogen fluoride. This is hydrocyanic acid or hydrogen cyanide. Hydrogen cyanide. Now I will now explain to you the chemical reactions. Okay, now this is formaldehyde. It could be any aldehyde, but we are taking the formaldehyde. All right. If we want to take the second aldehyde, acetaldehyde, then there will be CH3 here. Almost same pattern of the reaction. So HCN. As you know, in the HCN, this part is negative, so HCN is proton donor. So what do you expect? Can you tell me where will hydrogen go? Positive goes to negative. So hydrogen will attack on the oxygen. So there will be a new bond. Okay. And cyano group is negative, carbon is positive, so it's going to go to the carbon here. So you can easily predict and tell me the product. Okay, a very spontaneous reaction, and you will have HCOH and CN and H. Now this compound is called cyanohydrin. So you can convert formaldehyde to cyanohydrin when formaldehyde reacts with the hydrogen cyanide or hydrocyanic acid. This reaction is electrophilic addition reaction, forming a addition product which is cyanohydrin. Alright, I hope you get this. You can write CH2 also here. So if you want to know any other method of making this reaction, so it's a cyano group bonded to CH2 and CH2 bonded to OH. This is cyanohydrin. Alright, so this is the first addition reaction in the formaldehyde. I hope the example is working for you, and I hope you're getting this, how the displacement of the atoms is taking place here. It's not the actual mechanism of the reaction, however, but it just helps to understand just a reaction pattern, who is going where, what's happening, so on and so forth. Next, the reaction of the formaldehyde, which I will discuss with you, is the addition. It's a 2. I will make it again in Roman. This is the second part of the second string of reactions. It is addition of hydroxyl amine. Hydroxyl, okay, amine. Now hydroxyl amine is amine with OH. So amine is NH2 and ammonia is NH3, ammonium is NH4. So ammonium, NH4, ammonia, NH3 and amine NH2 bonded to hydroxyl. This is simple hydroxyl amine. Now if we want to make a reaction here, we will first write the formaldehyde, so which is HC double bond OH. I repeat, these reactions will take place in a similar fashion with acetaldehyde as well, or propionaldehyde as well. Any aldehyde, this is they're gonna work. Now, one way to write NH2OH is H NH OH, so that you have we can say that if oxygen has a partial negative character, carbon has a partial positive character. On this side, hydrogen is partial positive character due to electrophilic nature of nitrogen, and nitrogen has a partial negative character. So I just wrote NH2 as HNH, and I hope it doesn't matter, okay? I hope you understand. We can do that. Anybody can easily predict what's going to happen here. Hydrogen with partial positive character is going to approach oxygen, because hydrogen is electrophilic and oxygen is nucleophilic. And the NH will attack on the carbon, okay? So you can say like the carbon, right? And the positive will bond to carbon. So the double bond will actually open, and H will come to oxygen and NH will come to carbon. And if I can complete this equation, I can tell you that, let's say HCO, and let me make this H here and this H here. So who came on oxygen? H. And who came on carbon? The NH. This is an intermediate product. There's a lot of atoms bonded together. So it's not a stable, it's unstable. Unstable intermediate product. This product is unstable because of the presence of hydroxy and hydrogen atoms very dangerously close. And if you can understand what am I talking about, I'm talking about these guys. This OH and H are very, very close. If you can see that, OH and the NH, you know, they both have affinity for each other. So if I don't write this product here, and I extend with an arrow, you can write this one again and then proceed with the reaction, or you can write the 1, 2, 3 stage in a line. It's up to if you have space. Okay. Now, if these two make H2O, my friends, if these two make H2O, this bond and this bond, these valencies of nitrogen and carbon will be now free. So they can make overlap because there's a sigma bond already present between them. They can overlap to make a pi bond between carbon and nitrogen. And you are going to have a product, let's say H, C, H, and double bond N, and then OH. All right, plus H2O. This product is known as oxime. Oxime is also a new family of organic compounds in which amine group is bonded to the aldehyde. This one is called formaldehyde amine. If you had taken acetaldehyde, this is formaldehyde with one carbon. If we had taken acetaldehyde, and then we're going to get here acetaldehyde amine, okay? Or this is methanol amine, that would be ethanol amine. And as you increase the carbon, reaction doesn't change. The roadmap reaction remains the same. The water is eliminated because of this, they bond together, and this is the product, and the oxime is the final product of the addition of hydroxyl amine in the formaldehyde. Hope you will, I will recommend once again, do not write directly from the video, okay? Watch the video, do your research, look in the book, maybe check any other videos as well, and then once you are done, once all the prep and understanding is all clear, then you go for making your notes. So I would not like it if you put the textbook and then the notes and then the video and then you start to copy it from there. I don't like this idea. I think it's better first you individually research in everything and then put everything aside, and then you go with your work. In the work, if you are confused some places, you can just check around and then come back to your work as well. Hope these things are clear now. This is the addition of hydroxylamine, converting formaldehyde to oxime. Also conversion, okay? Third conversion is the addition of phenylhydrazine. Formaldehyde can add phenylhydrazine. Phenylhydrazine. Now, phenyl means contains benzene ring. Hydrazine is a name for compounds of two nitrogens, you know. So the formula is H2N, NH, and C6H5. Phenylhydrazine. But you know, we will write the structures rather open so you can understand. And you know, it looks pretty, plus it looks clear. Oxygen partial negative, carbon partial positive. And now I'm going to make this phenylhydrazine, and you have to pay attention. All right? Okay? You have to look very clearly. Now the H and then the NH. The H2N, okay? The next NH. There we go. And then the phenyl. Do you mind? Do you mind? No? Because C6H5 is better represented as a benzene ring. Now, the nitrogen being partial negative, hydrogen partial positive, I will need your feedback. What's going to happen? Hydrogen is going to attack on the oxygen here to make the OH. And this nitrogen is going to attack on the carbon. And if you can use your mind, you can tell me the product. Okay? I will try to save space here. Okay? So you have H, you have C, and then you have H here. And then now you have OH because the H has bonded to oxygen. And then you have NH, and then you have NH, and then you have a benzene ring. Phenylhydrazine. This one, as mentioned here, is unstable intermediate, which means it is not the final product. It's unstable. And if you were listening to this lecture keenly, you might have understood what's going to happen here. Removal of water. So now, when the water is removed, okay, what's going to happen? You will have here CH2, double bond nitrogen, because this valencies make a double bond here. And then the nitrogen bonded to the NH. You can go down, you can go up straight. And then NH bonded to a benzene. So this is phenylhydrazine, phenylhydrazine reacting with methanol or formaldehyde. The product is called phenylhydrazone. I have seen this conversion reaction many times in the past 20 years of my teaching. Convert phenylhydrazine to phenylhydrazone. Okay, how can you convert phenylhydrazine to phenylhydrazone? This is how you can convert it. So if your equations are fancy, the one who will check your copy will obviously understand that you understand the process. So addition of hydroxyl amine, addition of phenylhydrazine to phenylhydrazone, and the fourth one is the addition of alcohol. Addition of alcohol. Now, alcohol can also be added to formaldehyde, and it will then produce a new strain of compounds. Okay, so this is a formaldehyde, HC double bond O and H, with oxygen partial negative and carbon partial positive. Alcohol is ROH, and when we say alcohol, we mean ethyl alcohol, C2H5O and H. H is partial positive, O is partial negative. So what is going to happen? Where will the hydrogen go? The positive hydrogen will attack on the negative oxygen, and the oxygen will bond with the carbon. All right, a new form of functional group will appear. Let me tell you, HCOH and then OC2H5. This is a special compound where carbon is between two oxygens. If you know ether, in the ether, I will make here for you, if you can see it. In ethers, you see carbon, O carbon, oxygen between two carbons. This one has carbon between two oxygens. This is a new functional group, and they call it acetal, or this one is called hemiacetal. Acetal. Question remains, why hemi? Because this compound still has a capability to react with one more molecule of alcohol, all right, and form a complete acetal. So let me add here C2H5OH. All right. Now here I must tell you that this compound is basic. Okay. So the OH can be removed. It can accept a proton from here. So what do you expect? The OH from the H from the second alcohol atom, molecule, will make a dative bond with this oxygen, and ultimately this will break away as H2O, you know, and this will be replaced. You will see here there will be HCH, and then this will be replaced by OC2H5, and here's already OC2H5. This is called plus H2O. This is called acetal. This is a new strain of organic compounds in which the special bond is like this is a hemiacetal because it's OCO. This is acetal because it's COCOC. You know, carbon and oxygen are bond. This is a combination of like ether and hemiacetal. You can write this compound as C2H5 O CH2 and then O and C2H5, because the CH2 is bond between them. This is acetal. On next page, I will make a interesting structure of the this acetal. Okay, let me show you. So in the acetal, C is in the between. Right, there's CH2O, and then this is acetal. CH2, CH3, CH2O, CH2O, CH2, CH3. Because ethyl can be written as CH3, CH2. And then O, then CH2, then O, and then CH2, CH3. In the exam, sometimes they throw such structures which are hidden or not open, and then we are wondering what is it. So you should focus on acetals. So these 4 reactions, the addition of hydrocyanic acid, formation of cyanohydrin, addition of hydroxyl amine, formation of oxime, formaldehyde amine, addition of phenyl hydrazine, formation of phenyl hydrazone, and addition of alcohol forming acetal through hemiacetal. These 4 are basically electrophilic addition reactions of formaldehyde. Formaldehyde is very, very reactive than other aldehydes, and all aldehydes are more reactive than ketones because the carbonyl group is free, or it is on one side, In ketone, it is not free. So let us check the next reaction, which is the reaction with Fehling solution or Fehling solution test. Reaction with Fehling solution. And this third reaction is a laboratory test. What is it? Yes, it's a laboratory test. To differentiate between aldehydes and ketones. There's an interesting coloration in the whole process. The actual color of Fehling solution is deep blue. When it is added to an aldehyde, the reaction takes place and you get red coloration. And when you add it into a ketone, no reaction takes place and the blue coloration stays. So in this way, you can also it was used to differentiate between reducing and non-reducing sugars. For us, it's just a chemical reaction, but basically it's a laboratory test. Okay. Now I will put in some link. Link in the description. That link will take you, if you will go down to the description, then you click on the link, it will take you some other videos where the actual laboratory and actual test will be happening, and you could visualize why this Fehling solution is made. Fehling, it's Hermann von Fehling, a German chemist. If you know about Hermann von Helmholtz, Fehling's full name is Hermann von Fehling, and he made 2 solutions. One is called Fehling solution 1 and other is called Fehling solution 2. We in our textbook, we don't have to write about Fehling solution 1, or if you want to write, you can write when you will go to this link. you will know exactly the two solutions and their formulas. In our textbook, we are just seeing that when formaldehyde, HCHO, react with a mixture of copper hydroxide and sodium hydroxide. Now, apparently, you might guess that this combo is called Fehling solution. Yes, you can say, but this came from combining the Fehling solution 1 and the Fehling solution 2. You don't have to write this in your copy because that's beyond your syllabus. But to understand, because Fehling solution 1 is the copper sulfate, it's not copper hydroxide with the NaOH. And Fehling solution 2 is the sodium tartarate. So when they are combined, you make this thing. Okay. So when the reaction proceeds, it needs to be warmed. The content must be not heated, but warmed, just under the boiling point of water. You get the HCOONA as salt, sodium formate, 1 carbon formate, 2 carbon acetate, and you will get cuprous oxide. Now this cuprous oxide, the color of the cuprous oxide is red. Okay, these are red precipitates. The formation of red precipitates will indicate that the test tube you have contains an aldehyde. Glucose is also an aldehyde. So glucose will give a positive test. What's a positive test? The positive test is the deep blue coloration. If the deep blue color of the Fehling solution converts into red coloration, it indicates the presence of the aldehyde. And if it does not, it's a ketone. This discussion I'm doing with you verbally, but I wish I was in the laboratory and show you. That's why I went and searched on YouTube some laboratory scenario where you can actually see them reacting, and this is a test for the presence of the aldehydic groups. Free carbonyls, carbonyl with H, that's a free carbonyl. If the carbonyl is bonded to 2 carbon, that's not free carbonyl. So any species with free carbonyl will give you positive Fehling solution test, and by positive test I mean this becomes this. All right, the deep blue coloration goes red. It indicates the presence of free carbonyl group. Glucose is also an aldehyde. Next, I will tell you the third one is the Cannizzaro reaction. It's a Cannizzaro, just as it's a pizza, okay? It's an Italian name. The complete name of this chemist is Stanislao Cannizzaro. Why these names? Why sometimes some reactions have the name of the chemist who do them? Because sometimes when a species behaves differently or get out of the normal pattern of reactions, okay, then those reactions and their products are named exclusively. So here I must give you or tell you that all aldehydes, okay, and ketones, they can be converted into enols. Convert into enols. Now you might be thinking that what is enol? enol basically is a functional group, or it is for the higher classes. In our textbook, they had never mentioned anywhere enol. Okay. En for alkene, ol for oxygen or alcohol. So enols are very reactive species, and they make ions called enolates. I'm very sorry, it's not in our syllabus, but I'll just make for you, okay? So you can see that this double bond, and this is a double bond O. Now this is enolate ion. Now enolate are very reactive species, and they are used in synthetic industry to make a lot of new compounds. Aldehyde and ketones convert into enolate, and from there they react. This is not for formaldehyde. Okay? Enolate, then make new compounds. The process of conversion of aldehyde and ketones into enols is called aldol condensation. All right? Aldol condensation. Aldol. Okay? Removal of water, so condensation. So basically, what is aldol condensation? Aldol condensation is a process in which all aldehyde and ketones or carbonyl compounds convert into enols, compounds with a alkene and also carbonyl. So this is done for all aldehyde and ketones, but formaldehyde does not do that. This is a simple test between formaldehyde and acetaldehyde. Okay, why this happens? Now this will open a new discussion, because the acetaldehyde has alpha carbon, the second carbon, which makes a pi bond. Formaldehyde does not have two carbons; it's just single carbon. Okay, so it cannot do aldol condensation. However, Stanislaw Kanidzero, he found that if we treat formaldehyde with HO, NaOH, a strong base, there are two molecules of formaldehyde, both are formaldehyde. In that case, one of the formaldehyde is oxidized to make HCOONA, and the other is reduced to make CH3OH. Now, how oxidize and how reduce? One formaldehyde gains oxygen, more oxygen in it. Other formaldehyde gains more hydrogen in it. This process is just like a self-oxidation reduction reaction. Like a same species is also oxidized and reduced. So one formaldehyde becomes sodium formate with more oxygens. Other is called methanol with more hydrogens. Now this reaction, the Kanidzero reaction, has an entire mechanism where one formaldehyde gets the OH, the nucleophile, and then removes proton, becomes formate ion. Then formate ion bonds to sodium, forming sodium formate, and then those H go to another formaldehyde for making the methanol. So this is called the Kanidzero reaction. This is a type of self-oxidation reduction reaction in which one species is oxidized, other is reduced. All right. So I just give you this just for your knowledge. However, you don't need to write it in your copy. Okay, it's not important for you. It's just for the upper classes. If anyone will continue to do masters in organic chemistry, they will see this in the future. Next is the reduction of methanol to methanol. Now, so far you have been studying that methanol is oxidized to methanol. Alcohols are oxidized to aldehydes. But what about if you want to reverse the reaction? We have to reduce it, add hydrogen. This is formaldehyde. You can take any aldehyde and you put this, mix it in ethyl alcohol. Formaldehyde is not reacting with alcohol. Alcohol is just a solvent. And then you pour some sodium metal. Now, if you know, there will be a side reaction. Sodium metal will react with the ethyl alcohol immediately and form sodium ethoxide. At that time, this hydrogen will be released as nascent hydrogen. And if you guys know what nascent hydrogen can do, yes, it is way more reactive than normal hydrogen. I'm so sorry, I made oxygen. Nascent hydrogen, okay? 2 atoms, let's say, okay? So, guys, one H will bond with oxygen, one with carbon. So this CH2 already becomes CH3 and that becomes OH. So this way, methanol is reduced to methanol. Formaldehyde to methyl alcohol. Methylaldehyde to methyl alcohol by reduction process. And for it, we will prefer nascent hydrogen, which is way more reactive. This is learned in the 2nd chapter of the inorganic chemistry already. All right? But the equations are not ending, and we are entering the next equation, which is a plastic. We can make a plastic from the a polymer of formaldehyde. Okay. Number 6. Polymerization of HCHO. Now, HCHO means formaldehyde, methanol. So, if you take 3 molecules of methanol, let's say carbon, double bond, oxygen. This is 1 methanol. And then you have carbon, double bond oxygen, the second one. And then you have carbon, double bond oxygen, the third one. Now you might be saying, where's hydrogen? So I'm sorry for that. Let's say there's a H and H. Formaldehyde? Is it formaldehyde? Yeah. H and H. Other formaldehyde, and then H, and then H. The other formaldehyde. 3 molecules. Okay. Now, if they are moderately heated or warmed, okay, 62 degrees Celsius is just below the boiling point of, So if you warm it with dilute sulfuric acid, now this is where you all have to pay attention. The pi bonds break. And there are 2 orbitals empty here and here. So this shifts here between oxygen and carbon. This shifts here, and this shifts here. Now, once this shifting is done, you will see CH2, okay, O, then O bonds to CH2, then CH2 bonds to O bonds to CH2, CH2 bonds to O, then O bonds to CH. So I just changed this CH2. So this is a polymer. This is 3 molecules of formaldehyde. This is called metaformaldehyde. Metaformaldehyde. This is also a chemical reaction or possibility for formaldehyde. You can polymerize formaldehyde with dilute sulfuric acid, and you take a polymer which is called metaformaldehyde. The last but not the least is the Tollen effect or reaction with Tollen's reagent. Now this is another test, positive negative test for presence of free carbonyl group and glucose. Formaldehyde, all aldehydes have it. Reducing sugars, non-reducing sugars, who can reduce it or who cannot, is just classified on the basis of formaldehyde reaction. So what is a Tollen's reagent? To make a Tollen's reagent, the most basic ingredient is silver nitrate. Now guys, we have learned this topic already once in silvering of mirror, silver nitrate. Now we add some silver, a small quantity of silver nitrate in an alkali such as sodium hydroxide. Alright, now they immediately react basically, and you see precipitates, kind of silver hydroxide precipitates, like the solution becomes kind of turbid, like a dark in color. Okay, this happens when you drop silver nitrate into sodium hydroxide. These are gonna make the solution turbid or dark. To make the solution clearer, we will add more ammonia. Now the liquid ammonia is called ammonium hydroxide. It's a solution of ammonia or ammonical solution. The water donates proton to ammonia, it becomes ammonium, and then OH minus bond to NH plus. So this bonding, if you add it and stir it a little bit, it will make a very clear solution, which is diamine, NH 3,2. This is a complex. This is aqueous, dissolved in water, totally transparent solution. It's called diamine silver. So diamine silver 1 hydroxide. Now this is the product to which we will add glucose or formaldehyde, and then the magic happens. Now this is the HCHO formaldehyde. This is our diamine silver. The silver metal is reduced from here, and pure silver metal is reduced. It deposits from the inside of the test tube, and from outside you will think that the test tube is now a mirror. That's how we make mirrors. If you were present in my class, 5th chapter, I have taught you how we make mirrors. It's called silvering of mirror. Okay? So what do? We take in a beaker sodium hydroxide, we add some amount of AgNO3, we shake it, we get a dark color solution. We add to that ammonia and we shake it, we get a clear solution, and then we clean a glass surface, we pour it on it, it spreads, it dries. From this side, it's a mirror now. And if this happens in a test tube or a beaker or a flask, you will see that it's going to be mirrored from inside. This test was used by Tollen to find the presence of silver of the free carbonyl group like formaldehyde and glucose. This test is nowadays used in laboratory. So because this is a laboratory test. So I will go again and find a link so that you can click on it in the description, and then you can click on it and you can go to some people and they will be showing you real chemical reaction and real silvering of the mirror test. That's it, my friends. We've come a long way today. 56 minutes, 1 hour. There's a lot of reactions, a lot of work today. I am hoping, fingers are crossed, that you get it, you understand it, and also you can make use of it in the annual examination. All right? You can pause the videos, learn them, check again. Once you have a complete control on the topic matter, then you go for the fairing the work. Do not fair it immediately, like just the videos uploaded and here you go. You start writing it, immediately copying it in your copies. Not like it. I don't recommend it. I want you to study, research, and once the entire research is done, then go check your textbook. Then once you do that, maybe check another book or notes that you already have. And then once that is done, once everything is done, then you should write these equations as practice on a rough page. Practice more and more and more and more, a couple of times. And once you think you can write these equations on your own, once you can understand that you can write the data before the reactions on your own, once you have completely mastered it and understood it, then you go to fair it. Please, will you do it? That will be great. That will be great. So yesterday, I'm sorry, I didn't actually. Making a video is a lot difficult than you can imagine. I thought it would be very easy, but it's actually not very easy. It takes 2 to 3 hours of preparation, then 2 to 3 hours of video making, then encoding and uploading, and once it's done, I'm so much tired that then I cannot see through the computer or phone anymore. So when my mind is get relaxed, then I go check the homeworks. But it doesn't mean that I don't like the homeworks. I check the homeworks and I feel so much happy when you guys share it with me. So please go ahead and do the lecture today and learn it. And I hope that we will finish our syllabus very soon. This is 9th chapter. We might end it this week or next week, and then the 11th chapter. So we will have a lot of time to revise and repeat. If any student, unfortunately, cannot see these videos, he or she can tell me and I can help them to give them these videos through USB or some other way. I will be very glad to help them, because we are here to help you in the vacation time and we want to make the most of our free time, so that when we come back in the month of June, we can take the preliminary exam immediately. All right. I hope that you have gotten the idea of formaldehyde. Tomorrow we will do the acetone, the first ketone, and once we are finished with formaldehyde and ketones chemistry, then maybe Friday again there will be a test. We don't want to engage your parents because they already work hard for you and they are already busy, but just a signature will make me happy that they are taking care of your work as well. Thank you so much. See you tomorrow with acetone. Stay home, stay safe. Goodbye.